Let us do some problems on conditional probability. An instructor has a question bank consisting of 300 easy true or false questions, 200 difficult true or false questions, 500 easy multiple choice questions, and 400 difficult multiple choice questions. If a question is selected at random from the question bank, what is the probability that it will be an easy question given that it is a multiple choice question? Here, it looks like a simple probability question. What is the probability that it will be an easy question? But we have to understand that it is a conditional probability, because what is the probability that it will be an easy question given that it is a multiple choice question? Once the probability of a condition is to be found out on another given information, that is called conditional probability. So, let us see. The given data we are going to organize in a table. True or false questions or multiple choice questions. These two categories, both of them have easy questions as well as difficult questions. The data says there are 300 easy true or false questions and 200 difficult true false questions. Then 500 easy multiple choice questions and 400 difficult multiple choice questions. Now, the given conditions whose probability need to be found out, let us name. The total number of questions is 1400. An easy question. The selected question is an easy question. It is a condition. Let us call it event A. Probability of A will be, out of 1400, total number of questions which are favorable to this condition. Altogether, how many easy questions are there? 880 easy questions are there out of 1400. So probability of the question being selected is easy question is 800 upon 1400. Now, we need to find the probability under a given condition. That condition says the selected question is a multiple choice question. What is the probability of this condition B? Probability of B. How many multiple choice questions are there? Look, there are 900 multiple choice questions. So the probability of the selected question being multiple choice question is 900 out of the total 1400. Now, as we have already observed, what we need to find out is probability of this condition given another condition. It is a probability of A given B situation. That is, probability of A given B is conditional probability of A given B, which is found by the formula. Probability of A intersection B upon probability of B. Now we need to know what is the probability of A intersection B. Which are the outcomes satisfying the condition A as well as condition B. That means how many questions are there which are easy as well as multiple choice. Let's go to find out from the table. Easy multiple choice questions. These 500 questions are easy as well as multiple choice. Therefore, this 500 out of total 1400 is the probability of the intersection, the common elements. Upon probability of B is already 900 by 1400. On simplification, we get the answer 5 by 9. Given that the two numbers appearing on throwing two dice are different, find the probability of the event. The sum of numbers on the dice is 4. Here, we need to find out the probability of getting the sum of dice 4, but under a given information. It is given that two numbers appearing on the two dice are different. Now, under this given information, when we are asked to find out this probability, it is nothing but It is a conditional probability. Let's look at the sample space. This is the sample space of a pair of dice being thrown. Now, one event says the two numbers appearing on the two dice are different. Which are those outcomes? Except these diagonal elements 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Except them, rest all satisfy this event. Two numbers appearing on throwing two dice are different. Event A. So probability of A will be these 30 elements except these 6 of them, rest all are favorable. Different elements on two dice. So the probability is 30 upon 36, probability of A. Now, this is the given information. Now find the probability of the event. The sum of numbers on the dice is 4. Sum 4. Which are the outcomes having sum 4? These are the ones. 3, 1, 2, 2, 1, 3. Sum 4. 3 elements are there. So, probability of B will be 3 upon 36. There are 36 equally likely outcomes. Now, observe the statement once more. Given that A has happened, find the probability of B. So we need to find the probability of B under the given information A. Under the given information that A has happened. So what we need to get is probability of B itself. Hence, it is a conditional probability B given A. Observe it please. It's not A given B. It is B. We want to find the probability of B given this condition A. So probability of B given A we are going to calculate using the formula. Probability of B intersection A upon probability of A. To get the numerator probability of B intersection A, let's see which are the outcomes satisfying both of the events A and B. That is, the numbers are different as well as the sum is 4. Yes, we have two of them. 1, 3 and 3, 1. 1, 3 and 3, 1 will satisfy both conditions. Hence, the numerator probability is 2 by 36. Only two outcomes. 1, 3 and 3, 1. So 2 by 36 upon probability of A was already 30 by 36. Use here. So on simplification, we get 1 upon 15.